Good morning, everyone. Myself Sudharani. Today, let us discuss about classification and probabilistic classifiers. Classification is a fundamental task in machine learning and data mining, where the goal is to assign predefined categories or labels to input data based on their features. Probabilistic classifiers are a specific type of classification algorithms, but not only predict the class labels of input data, but also provide a probability or likelihood estimation for each class label. Classifications, here we are having two types of classifications: binary classifications and multi-class classification. Binary classification involves categorizing data into two classes, such as spam or not spam, positive or negative, sentiment, etc. Multi-class classification involves categorizing data into more than two classes, such as classifying emails into different topics, classifying images into different objects, etc. So here the classification is dividing the data sets into different categories, and classification can be done on two types. First one is a binary classification, second one is a multi-class classification. Whereas in the binary classification, the categorization of data into two classes, binary is two, so the classification will be done by using two classes. Generally, binary classification we can use whether to decide either true or false, high or low, negative or positive, pass or fail, yes or no, like that. So the decision between two cases, we go with the binary classification. And multi-class classification, in some situations the classification cannot be stick to only two classes like binary classification, but the classification has to be done multi classes, just like colors. Whereas the classification of colors can be done depends on the number of colors available. We cannot say colors only black and white. Okay, let us take one live example. In the olden days, the cinemas or the pictures, photographs are only binary classification. That is, whatever the real colors are there, but on the screen, all the colors can be represented by only two colors, that is white and black. That comes under binary classification. In nowadays, in movies and in pictures, in movies and in images, we are seeing all the real colors, and we are seeing more colors, and that comes under multi-class classification, where the classes can be divided, depends on the requirement. Probabilistic classifier are classification algorithms that not only predict the class label of input data, but also provide a probability or likelihood estimation of each class label. Probabilistic classifiers are classification algorithms, but not only predict the class label of input data, but also provide a probability or likelihood estimations for each label class. Okay, let's take the example of any online stores or any online website, shopping websites. There, the feedback can be done like reviews can be done like 4 out of 5, 3 out of 5. But we are having we see the comments. So where the comments, by seeing the comments, we can give the review rate as 4 out of 5, 3 out of 5. So such kind of things are called as probabilistic classifiers, where along with the classes, it is class labels, it is also going to give the probability. Means by seeing the comments, we can get the review out of 5 points, how much of the probability that the product got. That is an example for probabilistic classifiers. And here we are having Bayesian's classification, Navi Bayes classification, probabilistic output. Bayesian's classification. Bayesian's classifiers are a common type of probabilistic classifiers based on Bayes' theorem. They calculate the probability of each class given the input features and select the class with the highest probability. So in the Bayesian's classification, classifiers are a common type of probabilistic classifiers based on Bayes' theorem. Here, calculate the probability of each class given the input feature and select the class with the highest probability. For example, we take some range of, for example, the grading of the marks. A grade, if we categorize the grading of the marks like A, B, C, D, then A may be from 80 to 90 percentage, B may be some 70 to 80 percentage, like that. So within the range of class, so lower range to higher range, the class will be varies. And here the highest probability will be considered in the Bayesian's classification. Like if A grade is 80 to 90 percentage, then the highest probability is a 90 percentage. So like that, Bayesian's classification can be done. And next is the Navi bias classifications. Next is the Navi bias classification. Navi bias is a popular probabilistic classifier that assumes independence between features given the class label. Despite its simplicity, it often performs well in practice and particularly efficient for text classification tasks. So Navy bias is popular probabilistic classifiers mainly used for the classifications of text. Probabilistic output in classification, data classification, mainly we will use a Navy bias, and it is a best suitable algorithm for the text classification tasks also. Next, probabilistic output. Instead of providing a hard class label, probabilistic classifiers output a probability distribution over all possible class labels. This can be useful for decision-making process that require uncertainty estimation or for cases where assigning a single class label may not be appropriate. So the probabilistic output, instead of providing a hard class label, probabilistic classifiers output a probability distribution over all possible class labels. So this can be useful for decision-making process also that requires uncertainty estimation or for cases where assigning a single class label may not be appropriate. If you see here, when we see the probabilistic classifier, the general definition of a probability classifier is to label each class. But in some situations, labeling a class, one label may not be sufficient. One label may not be sufficient. One label may not be sufficient to label the class. So in that situation, in that cases, single class label may not be appropriate. In that cases, we are using the probabilistic output. Probabilistic classifiers offer additional insights beyond simple predictions by providing a measure of confidence or uncertainty associated with each prediction. This information can be valuable in applications where decision making involves accessing a risk or making informed choices based on the likelihood of different outcomes. Next is a linear classifiers. Up to now, we see in the probabilistic classifier, where in the probabilistic classifier, we are having the Navi bias, we are having the Bayesian's classification. And now let us see the linear classification, linear classifiers. Linear classifiers are a class of classification algorithm that make predictions by combining linear combination of the input features. This classifiers assumes that the relationship between the feature and the class labels is linear, meaning that the decision boundary separating different classes in a linear functions. Generally, the linear means the step-by-step procedure where the linear classifiers are a class of classification algorithm that make prediction by combining linear combination of the input features. This classifiers assumes that the relationship between the features and class labels is linear. Linear decision boundary. Linear classifiers defines a decision boundary that separates different classes in the feature space. This decision boundary is typically a hyperplane in higher dimensional feature spaces. For binary classification, the decision boundary is a line, means in 2 dimensions, or a plane in 3 dimensions. Here, the linear decision boundary is, here it defines a decision boundary between 2 classes. Here, the decision boundary will be separated different classes based on its feature space. For example, let us take the previous example only. The results grading is different grading like A, B, C, and D. So the difference between here, a student got who got 80% to 90%, they belongs to the grade A. Whereas if the student even got 79.99, they belongs to B grade. So here the clear separation of the boundary will be there. So such kind of decision boundaries are called as linear decision boundaries, where it is going to separate the different classes. Here the linear decision boundaries can be of 2 types. That is, the boundary is a line in 2 dimensions or a plane in 3 dimensions. Linear models. Linear classifiers are based on linear models that learn the coefficients associated with each feature and combine them linearly to make prediction. Decision functions of linear classifiers can be represented f of x equal to w to the power of t into x plus b. Here, where x is the input feature vector, w is the weight vector, b is the bias term, w to the power of t denotes the transpose of base vector, and the decision boundary is the set of points where f of x equal to 0. Examples of linear classifiers. Logistic regression. Despite its name, logistic regression is a linear classifier commonly used for binary classification tasks. It models a probability of positive class using a logistic function. Logistic regression, despite its name, logistic regression is a linear classifier commonly used for binary classification task. So here the logistic regression will be used for the binary classification. In the previous slides, we've seen that the classification can be done in 2 ways. First one is a binary classification and second one is a multi-class classification, where the binary classification can be done when the decision has to be taken between the only 2 classes. And if the decision has to be taken between more than 2 classes, then we go with the multi-class classification. Here the logistic regression, which is the example of linear classifiers, can be used for binary classification task. Support vector machines, SVM, this is a very popular classifiers for the image classification. Support vector mechanisms is a versatile linear classifier that finds the optimal hyperplane that separate classes with the maximum margin. So that's why the support vector mechanism machines are used much in image classifications. And here for the text classification also, we use a support vector machines as a part of linear classifiers to retrieve the data from the data sets. Perceptron, the perceptron algorithm is a simple linear classifier that iteratively updates the weights to minimize classification errors. So to minimize the classification errors, we are using the perceptron algorithm. Linear discriminant analysis, LDA, linear discriminant analysis, LDA. LDA is a linear classifier that models the distribution of each class as a multivariant and finds the linear discriminates that maximizes class separation. So one more example is the linear discriminant analysis, LDA. This finds the linear discriminant that maximizes class separation. So these are the few examples for the linear probabilistic similarity-based classifiers. Similarity-based classifiers, also known as instance-based classifiers or lazy learning algorithms, make predictions based on the similarity between the new input data and the instance in the training data sets. Instead of learning explicit model from the training data, these classifiers store the entire training data sets and make predictions by comparing the new instances to existing instances. So similarity-based classifiers means where the existing data sets are already, the existing data sets and the new data sets comparison will be happen. When the new data set or when the new data is entered, then the similarity based classifier it will compare with the existing data sets already which are there in the database. So instead of learning express model from the training, so instead of making the new data to train again, then it simply compare the new data with the existing data sets. Then with this, we can do the classification much better, accurate, and fast. So similarity-based classifiers are also known as instance-based. So that's why instance-based classifiers. Why? Because it is called as an instance-based classifier. It gets a quick classification. Or lazy learning algorithms. Why? Because it never make the new things to train again. Instead of the training the data sets again, simply it will whatever the training data sets are there in the existing database, simply the new data set will be compared with the existing data sets in the database. Principles of operation. Similarity-based classifiers make predictions based on the similarity measures between the features of the new instances and those of instances in the training data sets. The assumption is that the instances with similar feature vectors should belong to the same class. So within the similarity-based classifiers, so just now we've seen that the similarity-based classifiers means only to check the new data set, either it is same with the existing data sets or not. Means simply we are doing the comparison instead of giving the training to the new sets. Here, nearest neighbor algorithm, the most common type of similarity-based classifier is the k nearest neighbor algorithm, that is also famously called as KNN algorithm. In KNN, the class label of a new instance is determined by the majority vote for classification or the average for regression of the k nearest neighbors in the feature space. The choice of the distance metric plays a crucial role in determining similarity. So for the similarity-based classifiers, the most popular algorithm we use is the nearest neighbor algorithm. This is the most common type of similarity-based classifiers. So here the class label of new instance is determined by the majority vote. For example, in our existing data sets, we are having some 1,000 number of data sets, and the new one match up with the 800 of data sets. Then we can say that the similarity is matching. If the majority of the data sets out of the 1,000, the new data set is only match up with the 300 of existing data sets, then there is the dissimilarity in the new data set and the existing ones. So this is the concept of the nearest neighbor algorithm. Key concepts of nearest neighbor algorithm. If the parameter k in KNN specify the number of nearest neighbors to consider when making prediction. So here the parameters k in KNN means what are the nearest data sets. For example, if you take any word just like artificial. So artificial is the new word which we are going to search, and by using the similarity based algorithm, so whatever the data sets words are having with the combination of artificial, then it is called as the k, means the parameter of k. Distance metric. The choice of distance metric affects the notion of similarity between instances. Different distance metrics may be more appropriate for different types of data and feature spaces. So distance metric, the choice of distance metric affect the notion of similarity between instances. Different distance metrics may be more appropriate for different types of data and feature spaces. So, for example, if we take the choosing of the parameters should be carefully done. Why? Because if the parameters to be chosen wrongly, then the similarity may not be happen. So, if the words which are distance means which are long also can be considered instead of choosing the wrong word. Weighting, some variations of KNN assign weights to the neighbors based on their distances to the query instance. Closer neighbors may have more influence on the prediction. For example, let us take one more example. Here, artificial intelligence, latest articles. That is the query which I want to take one live example and do the things. Here I am searching for. I want to search for some latest things about the artificial intelligence. See here, automatically I got artificial intelligence. Okay, so if you simply type as artificial intelligence, we are getting the general data. I mean, instead of that, I will give like artificial intelligence articles for students. Artificial intelligence articles for students. See here, if you search the whatever the thing we are getting, first one, it is the most nearer one. So for me, I got the search, introduction to AI, types of AI, how AI works, so and so and so. And the next link, I got artificial intelligence. Some link I got this one. Means this is also very nearest one. And next from the Brookings, I got how artificial intelligence is transforming in the world. Next, US Department of Education, I got artificial intelligence and the features of tech teaching. And AI in schools, pros and cons. Next, like that, some Virginia Tech Engineering, AI, the good, the bad, and the scary. SA and AA. See, also when we are going for the next page, the impact of artificial intelligence and human loss induction, 4 scientist articles on AI and ChatGPT. What is means when we are going some distance, when we are moving to the next pages, the exact matchup cannot be done. So combination of the search word can be happen. If you see this is the first and second pages, just go to the 10th one. Just go to the 10th one. See the use of artificial intelligence platforms in higher education have affected artificial intelligence helping students. Universities say they are preparing students from the see. Somewhat the reliability of the search word maybe varies. The distance is increasing and the matchup with the search word may be diluted, and the combination of different things can be happen. exactly we are searching for the artificial intelligence, but see how students are using AI for homework, the integration of artificial intelligence into question, like so. The searching word will be matched up with another possibility words. Exact same word cannot be done, but the matchup can be happen. So this is some example I want to give for weighing. Means see the some variations of Canaan assign weights to the neighbors based on the distance to the query instance. So close neighbors have more influences on the prediction. So just now we seen in the search engines that the closed ones are having more possibility of the exact word of searching rather than the distanced one. Multi-category ranking. Multi-category ranking and classification. Multi-category ranking and classification involve assigning multiple categories or labels to input data and ranking them based on their relevance or confidence scores. So we've seen that we are having two types of classifications, that is binary classification as well as the multi-class classifications. So this multi-category ranking is also comes under the multi-class classification, where the classification can be done depends on the more classes rather than only two classes. This task is common in various applications such as information retrieval, recommendation systems, and content classification. Multi-category classification. So just now we seen multi-category classification or the multi-class classification, also known as multi-class classification, involves categorizing data, input data into more than two classes or categories. Various machine learning algorithms can be used. Various machine learning algorithms can be used for multi-category classification, including decision trees, support vector mechanics, logistic regression, neural networks, and assembling methods like random forest or grading boosting. Evaluation. So what are the methods we are using in the multi-category classification? Means we are using various machine learning algorithms, can be used for multi-category classification, include decision trees. Here, these are some methods or the algorithms we can use for the multi-category ranking, like decision trees. Support this all are the classifiers, decision trees, support vector mechanisms, logistic regression, neural networks, and assembling methods like random forest method or gradient boosting. Evaluation. Then how the multi-category ranking can be evaluated. The evaluation, the performance matrix for multi-category classification include accuracy, precision, recall, F1 score, confusion matrix, and multi-class ROC curves. Multi multi-category ranking classification. Ranking algorithms often use probabilistic models or scoring functions to assign relevant scores to each category. These scores can be ranked to determine the most relevant categories for the input data. So for multi-ranking methods, maximum ranking algorithms often use probabilistic model or scoring functions to assign relevant scores to each category. These scores can be ranked to determine the most relevant categories for the input data. What is a relevant score? Relevant scores can be based on various factors such as the likelihood of the input data belonging to each category, the similarity between the input data and the category representation, or user performance in recommendation system. So these all parameters are comes under relevant score, like what is the likelihood of input data belongs to which category, and what is the similarity between the input data and the category representation, or user preference in recommendation system. So all these parameters can be calculated as relevant score. Next, evaluation. Evaluation metrics for multi-category ranking includes pressures at K, mean average pressure, normalized risk on cumulative gain, and rank correlation measures like Spearman's rank correlation coefficient. So this is about the classification. Now we've seen, so in here, in this topic, we've seen what is the classification, and again the classification of two types, binary classification and multi-class classification. And what is a probabilistic classifier? Probabilistic classifier will give the class label, and under the probabilistic classifiers we are again having the Bayesian classification, where the Bayesian classification gives the highest probability within the range. Next, Navi bias. Navi bias is mainly used for the text classification task. And probabilistic output, in the probabilistic output it assign a single, yeah, it will useful in the situations where a single label may not be appropriate or may not be useful. Linear classifier, and again the linear classifier, what are the linear boundary, linear decision boundary, what is a formula, and examples of linear classifiers, again logistic regression, SVM, support vector machines, perceptron algorithm, linear discriminant analysis. Next, similarity-based classifiers. First, we see in the probabilistic classifier. Next, linear classifier. Next, similarity-based classifiers. So the similarity-based classifiers here, it is also called as the instance-based classifier or the lazy learning algorithm. Here in the similarity-based classifier, it will just compare the new input to the existing data sets, and if the majority votes of the existing data sets will come, then the similarity is high, or if the majority of the existing data sets are low, then the similarity will be low. So like that the similarity classification can be done. And in the similarity based classifiers, main algorithm is the nearest neighbor algorithm, that can also called be as KNN algorithm. KNN algorithm, just now I said that the KNN algorithm works on the majority vote, so majority vote of the existing data sets. Key concepts, K parameters in the KNN specify the number of nearest neighbors, and it is having the K parameters in the KNN is a K parameters K, and distance metric, weighting. Advantages and limitations. Advantages, simplicity and flexibility are the primary advantages of similarity-based classifiers. Limitations, they can be computationally expensive, especially with large data sets. Multi-category ranking. In the multi-category ranking, the methods we can use like decision tree, support vector mechanism, logistic regression, neural networks, and assembly methods. Evaluation, performance evaluation can be done with the accuracy, precision, recall, FN score, confusion matrix. Relevance score can be calculated with the likelihood of the input data, similarity between input data and category representation, user preferences. For the evaluation, it use the pressures at P at the rate K, mean average pressure, normalized risk on cumulative gain, and rank correlation measures. So this is the small introduction regarding the classifiers. Again, the classifiers, what are the different types of classifiers, and in each classifier, what are the measure, what are the methods using, what are the evaluation metrics using, and what are the algorithms using. Now, let's move to the next one. Let's move to the next topic. Next, move to the next topic, clustering. Up to now, we've seen the classification, the definition of the classification, what are the classifiers, and now let's move to the clustering problems. Clustering is a fundamental task in unsupervised learning that involves grouping of a set of data points into clusters or subgroups based on their similarity or proximity. Unlike supervised learning, where data is labeled with predefined classes, clustering algorithms discover the inheritance structure in the data without any prior knowledge of class labels. Let's see the definition of clustering. Clustering is the process of partitioning a data sets into groups called clusters, where data points within the same clusters are more similar to each other than those in another cluster. So see here the classification is different and clustering is different. Clustering means based on the similarity and dissimilarity that the data sets are going to be divided into different groups. They are called as clusters. So where the data belongs to the same cluster, that the points of each data, similarity of each data will be very near in the same cluster when compared to the different clusters. If we see, let's take the live examples of different states. If we see the different states of India, uh, take the state of Telangana and the neighbor state Maharashtra. So if you take, they are very near, and we can travel from Telangana to Maharashtra, and it is very near. But if you see the similarity of the people, either in the language or dressing or customs and festivals, everything is different from one state to another state. So that is the thing here I want to tell, like the cluster, the people in the Telangana district all belongs to the same culture, same type of slang or the language they are speaking, locality, customs they are having, celebrations of festivals. So in the cluster, the data whatever layers in the cluster, the similarity between the data is very close, very near to that next point of the cluster, where it is different from neighbor clusters, just like our state and just like our districts. The goal of clustering is to find natural groupings or patterns in the data, revealing underlying structures or relationship. See here, clustering. See here, like this, we are going to cluster the things. Here we are having it is a cybersecurity technologies. In the cybersecurity technologies, here we are having the different clusters like symmetric cryptography, asymmetric cryptography, blockchain, digital signatures, Web3, hash, RNG. These are in the cybersecurity technology. These are different clusters. So symmetric cryptography, this is one cluster where the algorithms or whatever it may be, it will be match up with the same thing. Again, the asymmetric cryptography is different, and the blockchain is a completely different digital signature. So these all are the clusters. Okay. So here it is showing it is together, and here it is showing the different clusters. Here we are showing the clustering with different colors. Yes, here we can see mitotic nuclear division, microtubule organized fission. So like every cluster, here we can see U1, R, G, E, N, N, G, E. These are the clusters name. And every cluster is represented with different colors. So in NLP, we can distinguish the clusters according to the same one. If you take here, A knowns you, credential recovery, articles, NLP. So in the credentials recovery, we can have customer care. Can you help me? I have forgotten my password. Credentials recovery. We are having the username and the password settings. AI know you. Here it is a chat with or call with AI. Writing articles, and it is a NLP. Objectives of clustering. Objectives of clustering. Maximize intra-cluster similarity, minimize inter-cluster similarity, discover hidden patterns. See, maximize intra-cluster. Intra-cluster means within the same cluster. Inter-cluster means between the different clusters. Maximize intra-cluster similarity means the data points within the same cluster should as be similar as possible. Minimize intercluster similarity. Different clusters should be distinct from each other. Discover hidden patterns. Clustering is widely used for exploratory data analysis. Clustering is a process of dividing a data into groups that is called as a clusters, and the points within a cluster are more similar to each points than to those in another clusters. The similarity is usually determined using distance metrics such as, here we are having Euclidean distance formula and Manhattan distance formula. Cosine similarity, here we are having the formulas to determine the distance metrics for the clustering. Applications of clustering. The most important application for the clustering is search engine optimization, where it improves relevance ranking and query expansion. And search engine optimization, if time permits, I will take one more class exclusively on the search engine optimization. So search engine optimization improves relevance ranking and query expansion. Topic modeling automatically groups similar content for better browsing. Personalized recommendation suggests content based on user preferences. Duplicate detection, identify redundant documents to reduce indexing load. So these are some of the applications of clustering: search engine optimization, topic modeling, personalized recommendations, duplicate detection. Properties of good clusters. There are the 4 properties that forms the backbone of strong clustering setup: homogeneity, separation, compactness, connectedness. These are the 4 properties for good clustering. Homogeneity, it shows how much the points in a group share specific features. So what is the similarity between the points in the same cluster is called as a homogeneity. Separation, it measures how clearly a group stands out from others. So separation means from one cluster to another cluster, what is the differences clearly mentioned for the separation of one cluster to another clusters. Compactness, it tells if points in the same group stay close together. Connectedness, it checks how strongly each point belongs within the same group. So these are the four properties of good clusters. Benefits of clustering: spot hidden relationships, improves decision making, manages resource efficiently, enhance others analytical methods, detects our outliers and anomalies. Clustering versus classification. Learning approach in the classification, supervised learning approach in the clustering, unsupervised learning approach. Training data sets, uses a training data sets in the clustering, does not uses a training data sets. Methods in classification uses algorithms to categorize new database on the training set. Whereas in the clustering uses statistical concepts to divide the data sets into subsets with similar features. Labels are provided for training data. No labels for training data. Objective to find which class of new objects belongs to from a set of predefined classes. In the clustering, to group a set of objects to find relationship between them. Complexity. More complex compared to clustering, less complex compared to classification. These are the few points shows the difference between the clustering and the classification. Clustering algorithms. The most popular clustering algorithms are k-means clustering. In the k-means clustering, it divides data into a predefined number of clusters by minimizing the variance within clusters. So k-means clustering, it is having a predefined number of clusters by minimizing the variance within the cluster. So it will predefine the number of clusters, means like 5, how many groups it has to divide, like 5, 6, like that. So depends on that clusters only, whatever the data sets are there, it has to be adjusted within that clusters only. Examples is clustering news articles by topics. Example, politics, sports, or technology. So in the news articles, whatever the news the journalist will gather, that has to be fit in any one of the category of the newspaper or the social media news. So we cannot give the new title, new tag for our news. Whatever the tags already is having, according to that only the news has to be fit. This is called as predefined number of clusters, which is used in the k-means clustering algorithm. Next, hierarchical clustering. It builds a hierarchy of clusters by iteratively merging or splitting them. Example, grouping. Second one is hierarchical clustering. Builds a hierarchy of clusters by iteratively merging or splitting them. Example, grouping object reviews based on users' sentiments like positive, negative, or neutral. So in the hierarchical clustering, whatever the data, whatever the input we are taking, that input can be merged or split according to the criteria, according to the clusters. So hierarchical clusters mainly used for the decision making, to compare or to decide, like a decision making. It can be used like to give the feedback, either it is a positive, negative, or neutral, or pass, fail, or high, low, true, false, correct, wrong, yes, no. Such kind of things can becomes under the hierarchical clustering. Next, Gaussian's mixture models, that is GMM, assumes data points are generated from a mixture of several Gaussian distributions and clusters them accordingly. Example, categorizing tweets into overlapping themes or topics. Next is latent Dirichlet allocation, that is LDA, a generative probabilistic model used to identify topics within a text corpus based on Watt's distribution. Here the example is top modeling for organizing a library of research paper. DB-scan, that is density-based spatial clustering of applications with noise. Groups together points that are closely packed while marking outliners as noise. Example, identify spam messages based on semantic similarity. Next, spectral clustering uses the eigenvalues of similarity matrix to reduce dimensions before clustering. And again, the example is clustering similar text documents or user queries in a search engine. Affinity propagation, description exchanges messages between points to find exclaims and clusters based on similarity matrix. Example is grouping forums discussions based on conversation content similarity. Agglomerative clustering, a bottom-up approach that successively combines the closest clusters. Example, identifying hierarchical relationships in words usage across a text corpus. Ninth one is self-organizing maps called as SOMs. Neural network-based clustering that groups similar data into 2D grid for visualization. Example, visualizing text documents clusters in a corpus. 10th one is non-negative matrix factorization, NMF. It decomposes data into parts-based representations for clusters. Example is unsupervised clusters of news articles into themes or topics. Next is BERT-based clustering. Uses embeddings from pre-trained models like BERT with clustering algorithms. Example, K-means and DB-scan. Next, TSNE or UMAP-based clustering reduces high dimensional word vectors to lower dimensions for visualization and clusterings using algorithms like K-means or DB-scan. Examples are grouping similar sentences in a chatbot training data sets. So here these are some of the clustering algorithms. Here I mentioned so many names, and you can see what are the different types of clusterings we are having, clustering algorithms we are having. So here is the overall comparative analysis to organize the differences. Consider this table. Aspect, K means hierarchical DB scan. Approach, partition based K clusters. Tree like nested cluster, density-based variable clusters, parameters, number of clusters, linkage optional threshold, EPS, min sample, NLP examples, news topics, sports and politics like that. Tweet hierarchy, in the hierarchical it is tweet hierarchy, and in DBScan it is review clusters, and strength coming to k-means, fast scalable, hierarchy it is visual hierarchy, number of k needed, DBScan, noise handling, flexibility, flexible shapes, weakness, need k, assumes spherical clusters, hierarchical slow for large data, DBScan sensitive to EPS dimensionality, complexity. Here having the formulas for complexity of k-means, hierarchical, and DBScan. So here in this we seen the complete points about the clustering. Here it is a complete explanation regarding the clustering and its problems. If you check again, have a brief note again on the clustering problem. So coming to the definition, clustering is the process of partitioning a data into groups called as clusters. And we can take geographical, if you take the example of geographical clusters, we can have throughout the globe, we are having different clusters like countries. If you see, we are having the different clusters like geographical clusters. If you identify the geographical clusters, first countries, then countries, states, districts, mandals, villages, and colonies. Colony. Like we can say, we can take the different clusters, and the countries which are the countries are again divided into states and states. And if you see, here we are having one point like the goal of clusters is to find neutral groupings or patterns in the data, revealing underlying structures or relationships. A clustering is a process of partitioning data set into groups called clusters, where data points within the same clusters are more similar to each other than those in another clusters. If you see the example, here if you take the countries, if you take countries like America, and take another our country, India. So these two are completely different countries. Two are completely different countries, and the here, according to the definition of clusters, the points within the same cluster, the points within the same cluster should be very near to each other when compared with the points to the other clusters. If you take America, it's when we take America, its culture, first point. Okay, wait, we'll try to explain clearly. Let us take two countries and take some parameters like culture, and second one, food habits, customs, facilities, growth, mm, geography, geographic things. What is like that? If you point of any, if you point of any things, if you point out anything in these two countries, the culture is completely different. It can be easily identified within America. The culture is the people who are, even if you see the Indians who are traveling to America, who are staying there from so many years and who are adopted to that culture, they will be similar to that one only. So the culture within the America, everybody used to follow the culture and very near to that one. And when it comes to India, the culture for eh, all the Indians will be very near and very close. That's the point is telling that in the clusterings, in the same clusters, the points in the same cluster should be near or the close company. If you see, America culture is completely different from the Indian culture. But America culture, people, those who are living in America will be same. The Indian culture is completely different again from the America. But the Indian culture is same for the people, those who are living in India. So that is the thing which I want to explain regarding the clustering. Clustering is the process of partitioning data sets into groups called clusters where data points. This is the point I want to explain by taking the example where the data points within the same cluster are more similar to each other than to the those in another clusters. So this I want to explain. And see the thing I want to tell again, the objectives of clustering. See here, see the here raw data. We can see mixing of different data is inserting as input to the system, and by using the clustering algorithms, we can categorize into different clusters like apples, like guavas, like strawberries into different clusters. I will tell you the live example for this clustering. See, if anybody went to market, they used to carry only one bag for the to take the vegetables and everything. If they went to market with single bag and there with the vendors, the plastic covers are completely banned. Just imagine that the plastic covers are completely banned and the people went with only one bag. And in that same bag only, the people who are selling the vegetables, they used to put all the vegetables. First, that guy went for the tomatoes, and in the bag, the tomatoes was put by the vendor, put by the seller, and next he taken the mirchi, then chilies, then he taken the beans, then he taken the lady's finger, he taken the brinjals like that. When he comes to the home now, when he comes to the home, it is very difficult for him to take a single vegetable from the bag. Why? Because all the vegetables are mixed together. So to take the bag, to take the vegetables, he has to first divide the vegetables completely. Then only he can understand, he can categorize, he can classify which vegetables are there. If you take only one bag, if you take only one bag, we can't identify which vegetables are there. Then what the people have to do, then they have to take each vegetable separately and put in one cover or the paper and then keep in the fridge. So this is a simple thing of objectives of clustering. So for the objectives of clustering, we are having maximize intercluster similarity. So maximize, a main objective of the clustering is to maximize intra-cluster similarity. Intra-cluster similarity means just now I said this one. So within the America is the intra-culture, within the India is the intra-culture, but the relationship between the America and the India again called as the inter-culture. So always we have to try to strengthen the maximize intra-culture. So the unity should be there between the same clusters than the another clusters. See, take the example of latest. If you take the latest example of India and Pakistan war. So when it comes to the matter of the country, irrelevant to the religion, irrelevant to the state, irrelevant to the language, irrelevant to the breed of the people, everybody unitely fought for the country. Only one, then now that this part is not there. See, when it is the when it is a thing of country, then this concept is not there. States, districts, mandals, villages, colonies, that kind of clustering is not there. When it comes to the war between India and Pakistan, then this concept is not there. At that time, all clusters sought togetherly fought for the country. Only one cluster is there, that is the country, and that is where India and Pakistan. So all the people stood as one and fought for India. At the time, only the thing they understand is strengthening the intra-cluster similarity. That is the best example of maximize intra-cluster similarity, where the nationality should be the same thing for the Pakistan also. So the thing is strengthening the country. All together has to be fight for the India to secure the people of the India. So that is a maximize intra-cluster similarity. So it is data points within the same cluster should be as similar as possible. If the intra-cluster similarity is not more, then there is no scope for the clustering points. Next, minimize inter-cluster similarity. See, for example, if India, there is no difference between the India and Pakistan, means there is no much bond, there is no much similarity between the Indian people, within the Indian people and within the Pakistan people. Then if anything happens, it will be neutral, means nobody will take it seriously. Nobody will be, there is no love of the country, then nobody will fight for the country. So always we have to have the minimum inter-cluster similarity. Means another, India should be India. India should be India. It should be have its own boundaries. It should have its own customs. It should have its own priorities. It should not be much like another country, like with similarities like US or the Pakistan, like that. Then only if it is having the minimum inter-cluster similarity only, the cluster should be strong and the cluster should be divided strongly and fight for its own strength of the clusters. Discover hidden patterns. Clustering is widely used for exploratory data analysis. These are the objectives of clusterings. And to measure the distance of clusters, here we are having the three formulas from the three different concepts: Euclidean distance, Manhattan distance, and cosine similarity. We can use any formula to calculate the distance of the cluster. These are very important applications of clustering. Search engine optimization. This is the first and foremost application for the clustering. That is the search engine clustering. So search engine optimization. Nowadays, the world is rotating towards the search engines, chatbots, just for the information retrieval. So the chatbots and search engines are making the people very to do their work very easily and ready to use concept of data. They are getting by search engines or the chatbots. So the search engine optimization is very useful nowadays. So search engine optimization is one of the applications of clustering. Topic modeling. Personalized recommendation. So this is personalized recommendation, suggests content based on user preferences. For examples, let us say what is the personalized recommendations. If you in YouTube you are watching any video, for example, you are watching Chiranjeevi songs in YouTube. You are watching one latest song, and you are getting the ads, and it is scrolling up or down or side somewhat where it is scrolling next song of Chiranjeevi only. You are not at all clicking, or you are not at all seeing any another song, but automatically when you are watching one hero song means immediately the next song will also be the same hero song, or the news related to that hero, or the movies related to that hero, like that. If you take any if you are searching any online shoppings, you open your Google and search for any phone, iPhone or whatever in Amazon, immediately for your mails, even for SMS, even for WhatsApp also, you used to get the different advertisement from different websites related to the search. So this is the personalized recommendation. So in the personalized recommendation also we are using the clusterings. Duplicate detection. Duplicate detection identifies redundant documents for to reduce indexing load. So we've seen what are the different types of clusterings we are having, what are the different types of formulas we use to calculate the distance metrics, and what are the different applications we use for the clusterings, and what are the different properties having for the good clusterings. The different properties, the properties of good clusterings is homogeneity, separation, compactness, connectedness. These are 4 properties of good clusterings. Benefits of clustering. So benefits of clustering: spots hidden relationship, improves decision making, manages resource efficiency, enhance other analytical methods, detects outliers or anomalies. Spots hidden relationships, identifies, underlines links between data points that may not be immediately apparent, relieving patterns that would be difficult to detect by manually viewing data. So the things which are difficult to manually reviewing, then the spot hidden relationship can be used for the clusterings. Improve decision makings. Groups with distinct characteristics allows for target actions such as personalized marketing strategies based on customer purchasing behavior. Manages resource efficiency, organizing large data sets into smaller clusters, reduces processing time, enhances query performance and optimizes storage use, enhances other analytic methods, enable more advanced techniques like classification and predictive model. Clustering versus classification, we are having a lot of points where to difference the clusterings and classifications, like learning approach, where the classification is supervised learning, and whereas in the clustering it is unsupervised learning. And training data sets, in the classification it is uses the training data sets, and in clustering it uses the it not use the training data sets. So many people who don't have the deep knowledge about the things, that people will think that the clustering classification both are same, but no, definitely no. There is a lot of difference between the clustering and classification. Here we can see clearly labels are provided for training data sets, and for the clustering, no label for training data sets. Objective, to find which class a new objective belongs to from a set of predefined classes. In the clustering, to group a set of objects to find relationships between them. And complexity, more complex compared to clustering and less complex compared to classification. So overall, the differences of clustering and classification is classification is somewhat more complex compared to the clustering. This is very, very important, and again I am repeating, this is very important thing to remember. What are the different clustering algorithms are there, and what is the use, and what are the examples? These slides are very good and you people can go through it. It is a clear, you can understand it clearly what are the different clusterings algorithm and where we have to use it. First, k-means clustering, where it divides the data into predefined number of clusters by minimize the variance. Example, clustering news articles. Hierarchical clustering builds a hierarchy of clustering by iteratively merging or splitting them. Example, grouping product reviews based on user sentiments. Gaussian mixture models assumes data points are generated from a mixture of several Gaussian distribution. Example, categorizing tweets into overlapping themes or topics. Latent discrete allocation, a generative probabilistic model used to identify topics within a text corpus based on words distribution. Topic modeling for organizing a library of research papers. DB scan, density-based spatial clustering of applications with noise, groups together points that are closely packed while marking outlines as noise. Example, identifying spam messages based on semantic similarity. Spatial clustering uses the eigenvalues of similarity matrix to reduce dimensions from clustering. Clustering similar text documents or use queries in a search engines. So spectral clusterings mainly in the search engines. I want to tell you one point here. See here. In the search engines, right? In the search engines, if I type letter if I type letter M in my system, in my search engines, I'm getting the word machine learning articles or machine learning. And it may not be same for all the people and all the systems. So this is based on the priorities or the rank whichever marked in my data sets for each word. In some systems, in some laptops, if they simply type the word as letter as M, they may get the machine, they may get the maths, they may get mechanisms, they may get machinery, they may get which starts with M. So that is different. So here for me, I'm getting the M means this is the priorities based of the data sets of search engines. That is the point here specifying. Spectral clustering means uses evaluates values of similarity metrics to reduce dimensions before clustering. Documents or users queries in search engines. Affinity propagation exchanges messages between points to find exclumbers and clusters based on similarity metrics. Example, grouping forum discussions based on conversion content similarity. Agglomerative clustering, a bottom-up approach that successively combines the closest clusters. Identifying hierarchical relationship in word usage across a text corpus. C. Identifying hierarchical relationship in word usage across a text corpus. Like if you take a word like the example, walking on. See, let's take see. I simply given walking on. It is getting as walking on sunshine, walking on a dream, walking on eggshells, so and so and so. How it is getting? How I simply given the walking, or just take one more. Talking with talking with strangers, talking with AI, talking with auto, talking with something it is getting. So how it is getting? That is what? That is agglomerative clustering, identifying hierarchical relationship word usage across a text corpus. See here, I am simply giving in the text corpus, the hierarchy of the words will be there. See, now I given as talking with, then it is immediately getting the next prediction of word. Talking with, it is getting the next prediction of word. So such kind of things are called as the hierarchy relationship. And take one more example. One more example. College, see, college board, college admissions, college predictor, college so and so. So these things are called as, these things are called as, these things are called as, okay. So that is the agglomerative clustering, which is gives the hierarchical representation of words across a text corpus. And few more things are there, few more algorithms are there. That is DB scan. That is DB scan, density-based spatial clustering of applications with noise, groups together points that are closely packed while marking, and that is examples are identifying spam message. Next is spectorial clustering, that is cluster use the values of similarity matrix to reduce dimensions. Examples of clustering similar text documents. Next one, affinity propagation, that exchanges messages between points to find clusters based on similarity. Example is grouping forum discussions based on conversion content similarity. Next, agglomerative clustering, the bottom of approach that successfully combines the closest clusters. Identify self-organizing maps, neural networks based clustering that group similar data. Example, visualizing text document clusters. Next, non-negative matrix decomposes data into parts. Example, unsupervised clusters of news articles. BERT-based clustering uses embedded from pre-trained models. Example, clustering customers FAQs. Next, TSNE or UMAP-based clusters, like algorithms like K-means or DB-scan. Example is grouping similar sentence in a chatbot training data sets. And this is a clear comparative analysis to organize the differences. Consider this table, and here we are having the clear comparative analysis of the different algorithms, whatever we've seen up to now. And here we are having the aspect k-means, hierarchical D-scan, DB-scan. This is the clear explanation regarding the clusterings. In this lecture video, we've seen what is the classification and what are the different classifiers and what is the different clusters we are having. Hope you people understand my lecture. Thank you for your patience. We'll meet with another video.